Hi everyone, in this video we will see how to give analog outputs in Arduino. So there is more to study in analog input with real practicals like variable resistors, maybe LDR, maybe IR sensor and how they work, how to maybe how we can take that analog input using them, how we can connect them, things like that. But before moving on those practicals or on those topics, we will study about the analog output here, and then in the upcoming videos we will also know about the analog inputs with these variable resistor, IR sensors and things like that. So the examples of analog input, and also we can see how we can combine analog input with analog outputs as well. So before starting those analog input stuffs, we will study some introduction of analog outputs in Arduino. So we already studied a digital output, right? So where we use pin mode and also digital write, and also we studied about analog input. Now we are going to study about analog outputs. Okay, so what is there is yet to be done is digital input, right? That we will see later. So now it is going to be analog output. So first, as usual, what I will do is I will write the void setup and void loop. Void setup and let's write on top. Okay, void loop. All good. So as usual, what we will do is first we will have to say that which pin we are going to use for giving that particular analog output. So as I said we are using this A pins, okay, A prefixed pins for analog purposes, either it is input or output. So it can be A0 or A1. So you can go to Arduino and see these pin numbers. Actually those pins, some pins are there with the written A1, A2, A0, A3, things like that, with the names like that. So you can use any of that pin. Even actually to give analog outputs we can even use digital pins. So let's not talk about that now. Okay, let's use analog pins. All good. I'm sorry, I took a small break. So all fine. So as usual, you may remember how we created some digital outputs in Blink examples. How we used took some analog inputs in the previous videos. So like that, to give analog output also, first what is the thing we have to do inside void setup? We have to mention whether this is an input or output, and we have to do it only one time is enough. Doing it one time is enough. So we do that thing is in setup, void setup loop. Because if you say one time this is an output or input, Arduino will remember it forever. You don't need to repeat it. But you have to repeat it, the output. Okay, I'm going to continuously giving the output. Things like that you can repeat inside the void loop. So inside the void setup you will write pin mode. That keyword is going to tell you which pin I am going to use and why. That means as an input or output I am going to use it. So let's say I am going to use pin number A0. Okay, I'll give a comma and I will say whether it is an input or output. So in our case it is an output because we are going to give an analog output. Okay, so once we say this, so pin number A node is now ready to give an analog output. Okay, so in the void loop what we are going to do is whatever that is going to repetitively happen we are going to do. So what is that thing with going to repetitively happen? That analog output giving we have to give repetitively, right? Like LED building, something like that. So we are going to give an analog output in the pin A0. So we also already know when we are giving digital output we are using digital write. When we are taking analog input we are taking analog read. So you know write means output, read means input. So when it comes to analog input, what you will do is you will say analog. That is sure, right? Because we have to say which kind of output A0 is going to give. We are going to say analog output A0 is going to give now. So and then as usual, since it's an output, we will write like digital write. Now we have analog write. So digital write, what does it do is it is giving a digital output. Analog write will give an analog output. Then you have to mention the pin. Okay, and you have to mention a value. So you may think in the analog input we have the values from 0 to 1024 units. But when it comes to output, we are not capable of giving 1023 value. So 1024 values. So when it's come to output, the maximum value we can give is 255. That means 255. The minimum value we can give is 0. Okay. So it is same as okay, same as 1023 and 0 in analog output. Let's not ask why is that so. There are some reasons like why, because of this bit number of the timer and all. So just don't worry, we will explain it in another video. So now just remember, analog read we are using 1024 units, right? So in analog write we are using 256 unit. That means 1/4 of 1024 units. Okay, we are not capable of giving 1024 units when it comes to output. When it comes to inputs, we can use 1024 units, because you can go and watch the last video if you don't understand what I am talking about and come back, right? Then that will be easy to you. So when it comes to analog A0, 255 will be 5 voltage output. Okay, because as I said already, in analog input, if you give 5 voltage input, 1023 will be the output, right? Maximum value. But when it comes to an analog output, since 255 is our maximum value, so the 5 voltages and 0 voltage will be divided into 256 units. 256 units, that means 0 to 255. So 255 will be 5 voltage and 0 will be ground or 0 voltage. Okay, I hope this can be understandable. So just remember, in the analog write, we can give values 0 to 255. That means 256 values we are capable of giving. So and 255 will be, if you give 255 to a particular analog pin, that value will be that the voltage value in that analog pin output is 5 voltage. That means it is equal to digital high value. Digital write high value 250 will be equal to that. So 0 will be obviously 0 voltage, right? So if I want to give 2.5 voltage in that analog pin, okay, I'm sorry, 2.5 voltage, what is the value I have to give? So when it comes to digital write, I cannot give 2.5 value voltage. It's not possible, because digital have only 5 voltage and ground. That means high and low. So 2.5 voltage, how I can give? The answer is, we have the values, no? We can give an intermediate value. Okay. So since 256 units, that means 0 to 256 is 5 voltage, then 128, that means half of the 256 units, 128 units will be 2.5 voltage. So 128 means, since it start from 0, the end of the 128 values will be 127. If it is starting from 1, we can say 128. Since it is starting from 0, then 128th value will be 127. So that is the 2.5 voltage. So that's a half of this 255. Understood? So if you are to give 1.25 voltage, that will be half of this 128 units. That means 64 units. That means since it starts from 0, it will be 63. So you can see we can give 2.5 voltage output, 1.25 voltage output, and any intermediate output values. So what happens if you are changing these values? When you are changing the values, what happens? The thing is, the power, if you connect an LED to the A0, the power of the LED will be changing. You can even dim an LED and increase the LED's power or illumination from 0 to some extent. Slowly you can increase, slowly you can dim. I hope you can understand what I am talking about. So what I will do is I will give a full value. Okay, 255. And if I am connecting an LED to this, you can use it for any purpose. But if I am connecting an LED to this A0 pin with a resistor and connecting the other side to ground, then I may have to give a delay. It's not sure, because I am not blinking that LED. I am just making the LED on with full power. Let's say 100 milliseconds. That means less than 1 second. 1/10 of 1 second. Okay. So if you want to decrease that illumination of the LED, that means power of the LED, you can give that means after 100 millisecond, if you want to change that power of the LED, you can change it. Maybe a less value. If you want to make it by half, you can give 127. If you want to make it to the quarter, you can give 63. or you can give any value like some a little bit less than to full value you can give. So if you know, if you do the correct mathematical operation, you can find the value, voltage value for the 200 units. It is not that big deal. So you can give another delay. Okay, like that you can change the values with proper delays. Then you can see that LED is dimming, or you can increase the dimming also by increasing the value with proper delays. Okay, so I hope this is understandable. So you can change the value in the next line. You can have another couple of lines like this, and you can change the value like maybe 125, 130, like that you can change. So I hope you have a good idea about what analog output is, and what are the limitations from 0 to 255 you can give, and you can use an analog pin, and how you can implement it, like for which application you can use it, like LED blink, LED illumination, or dimming, things like that. So there's an example in Arduino software. You can find its name as FAD. So that actually use this analogWrite method with the for loop, I think. So just don't worry about that. Just remember what we have gone through in this video. So then you will understand. So now we have some idea about digital output, analog input, and analog output, hopefully. So thanks for joining in this session. I will meet you in this video. Until then, bye, have a great day ahead, and don't forget to subscribe our channel. Bye.